Now let us see theory of strain gauge or principle of strain gauge. So when a strain gauge is subjected to tension, that is positive strain, its length increases and its cross-sectional area decreases. And we know that since the resistance of a conductor is directly proportional to its length and inversely proportional to the area of cross-section, the resistance of gauge increases with positive strain. In addition to this, when positive strain is applied, the resistivity of the material of the strain gauge also increases. So this property is known as piezoresistive effect. So therefore, when positive strain is applied, the resistance of the material of the strain gauge increases because of increase in its length, decrease in its cross-sectional area, and increase in its resistivity. So now the gauge factor is a parameter which measures the change in the value of resistance of a strain gauge. Now what is this gauge factor? Gauge factor is the ratio of per unit change in the resistance to per unit change in its length. So gauge factor is given by, it is denoted by GF, which is equal to delta R divided by R divided by delta L divided by L. Delta R by R is per unit change in the resistance, and delta L by L is per unit change in its length. So now we know that resistance of the wire is given by a common equation, that is R is equal to rho L divided by A. So here rho is the resistivity of the material of wire, L is length of the wire, A is cross-sectional area of the wire. Now A can be written as A is equal to K into D square. So K and D are constants. D is a diameter of wire. K is constant and D is the diameter of the wire here. So this is the equation for resistance of wire. So if we substitute for A, which is Kd square, we get R is equal to rho L divided by Kd square. Now as we stated here, when the wire is strained or positive strain is applied, its length increases and lateral dimension, that is cross-sectional area, decreases. So let us analyze this change in the resistance mathematically. So differentiating this R, dr is equal to, so after differentiation we get k d square into rho into dl plus L into d rho minus rho L 2kd into d of d divided by kd square whole square. So further if we simplify this, we get 1 divided by kd square into rho into dl plus L into d rho minus 2 rho L into dd by d. Now if we divide this entire equation by R, both LHS and RHS must be divided by R, we get dr by R is equal to 1 by kd square into rho dl plus L into d rho minus 2 rho L into dd by d divided by whole divided by rho L by kd square. So if we simplify this, we get dl by L plus d rho by rho minus 2 d by d. Now Poisson's ratio is given by an equation, mu is equal to lateral strain divided by longitudinal strain. So in case of resistance wire, the lateral strain decreases when positive strain is applied, when the conductor is applied, when the conductor is stretched. So lateral strain is decreased. So that is why it is indicated as minus dd by d, and longitudinal strain increases, that is dl by L. The purpose of using negative sign here is when a metal conductor or metal wire is stretched, its cross-sectional area decreases. That decrease in the cross-sectional area is indicated by negative sign here. So therefore, d by d can be written as minus mu into dl by l. So now, after putting the value of d by d in the above equation, in this equation put d by d as minus mu into dl by l. In that case, we get this equation can be rewritten as delta r by r, which is equal to delta l by l plus 2 mu delta l by l plus delta rho divided by rho. So now we know that the gauge factor, according to its definition, it is given by delta r by r divided by delta l by l. So therefore we can write delta r by r is equal to gf gauge factor into delta l divided by l, which is equal to gf into E, where E is strain and it is delta L divided by L. So therefore, by dividing this equation by delta L divided by L, we can get, so LHS delta R by R divided by delta L by L is nothing but GF, gauge factor, which is equal to delta L by L divided by delta L by L is 1 plus 2 mu into delta L by L divided by delta L by L, that is delta L by L will be cancelled and only 2 mu remains here, plus delta rho by rho divided by delta L by L. The same we got here, GF is equal to 1 plus 2 mu plus delta rho by rho divided by E, where E is nothing but strain and it is delta L divided by L. So now in this equation of gauge factor, this 1 indicates the resistance change due to change of length. This 2 mu indicates resistance change due to change in the area, cross-sectional area. And this last parameter, that is delta rho by rho divided by delta L by L, indicates resistance change due to change in the resistivity, or it is resistance change due to piezoresistive effect. So now in this equation, if the change in the resistivity is very negligible, if the piezoresistive effect is negligibly small, in that case we can write GF is equal to 1 plus 2 mu. So this is the equation for gauge factor. So now this gauge factor depends upon Poisson's ratio mu. So Poisson's ratio for all the metals are different, and it lies, for metals it lies between 0 and 0.5. So maximum value of gauge factor for metal is 2. If mu is 0.5, GF will be 2 for metals. So therefore, knowing the value of gauge factor, the strain in the material can be directly calculated by the change in the resistance. So this is the importance of gauge factor here. If the gauge factor is known, we can easily find the strain in the material due to change in the resistance.